Welcome back to my channel. In today's video, we discuss Pauson reaction, which is a cyclization reaction in which our alkene, and carbon monoxide is reacted in presence of dicobalt octacarbonyl compound, and we use alpha beta cyclopentanone. Let's see the reaction. Here, our alkyne carbon monoxide react with in presence of dicobalt octacarbonyl. We get communal cyclic compound alpha beta cyclopentanone. Okay, here our alkyne alkene and carbon monoxide. Same thing, we can say that this is 2 plus 2 plus 1 cyclization reaction or cyclization reaction. In our alkene is react with alkyne is react with alkene in presence and carbon monoxide in presence of dicobalt octacarbonyl compound. We use alpha beta cyclopentanone. Here our carbonyl compound we call here alpha and beta. So alpha beta cyclopentanone. Now we discuss the mechanism. How can reaction is proceed? Now we discuss the mechanism. We having a catalyst is cobalt octacarbonyl. Okay. Here it is 18 electron species which cannot take a part in the reaction. Here dissociation takes place. Dissociation takes place and loss of two molecules of C. Okay. Before that, 18 electron. Here cobalt having a 9 electron. Then this one be 1, 10. This 2, 2, 2. Okay. This is 6 and here 1 and 1. This bridging carbon. Okay. Now 1 plus 9 plus 1, 10, 11, 12. 14, 16 and 18 electron. Okay, both cobalt atom having the 18 electron. Now after the dissociation take place and 2 moles of carbon is lost. Now we get 16 electron spaces. Okay. Then after here coordination of alkyne. Okay. This coordinate with alkyne. Then we get 18 electron spaces. Here, this moiety is as remaining and this alkyne formation of bond between this cobalt atom. This carbon form new bond with this cobalt and this cobalt. This carbon again formation of two bond, this cobalt and this cobalt. Okay, it is 18 electron spaces. Now, what will be the next step? In which again loss of one CO molecule. Okay, loss of one CO molecule. Now we get we can show this bond between colors and here it is again 18 electron is converted into 60. Okay. Now what will be the next process? First your 18 electron spaces undergo the dissociation, loss of 2 moles of 2 molecule of CO molecule. Then we use 16 electron spaces. After the 16 electron spaces is coordination of alkyne with catalyst. Okay. Then we get this structure which is 18 electron spaces. Then after we loss of one carbon compound, then we get finally this type of the structure. After we completed, then I can rub this. After the loss of one carbonyl molecule, then we get this type of species. Now, here, this molecule again coordinate with alkene. With alkene. Okay? Then we get what will be the product? Okay. Now we get this or other. This is our alkene. Okay. After the coordinate with alkene, here migratory insertion. Of alkene. Here, this alkene is migratory insertion reaction take place. How can migrate? This alkene group is formation of new bond between this carbon and this cobalt. This bond will be break. Okay. Now, what will be the product? This moiety is unchanged or showing with colorful chalk. Okay. This bond is as remaining, but bond break between this carbon and this cobalt. Okay. Here alkene. Okay. This alkene is migratory insertion take place and formation of this type of the species or this type of the cluster. Now, after that, it again addition of one carbonyl, third carbonyl. Okay, the cluster undergo addition of carbonyl molecules. Okay, do not confuse this molecule called as a cluster. Okay, this cluster undergo C one molecule of carbonyl or CO addition. Okay, this simply write here addition of one CO molecule. Where will be the addition take place? At this position your carbonyl will be added. Okay. Now what will be the product? This moiety is unchanged. Here addition of one carbonyl, then okay R dash, and here our alkane, which is bond between the cobalt and alkane. This is our alkyne moiety, this is our alkene moiety. After the addition of one carbonyl molecule, then migratory insertion reaction take place. You know that migratory insertion means this carbonyl group is addition between cobalt and this alkene carbon. Okay, this carbon we can show it with colorful. Here, migratory insertion of that carbonyl or one CO molecule in between cobalt and this carbon. Then, what will be our next step here? Migratory C. Okay. Now shall I rub this? Here now we get this is first unchangeable. Now this is our alkyne. Here this carbon bond between, okay, this cobalt bond between this alkyne are our substrate. Now insertion of new carbon. Okay, here migratory insertion of one carbon. Here only two carbon will come or two molecule of CO is combined with cobalt. Now again addition of carbon monoxide, new carbon monoxide. Okay, then we get here, always remember that side is unchangeable. Then what will be the structure? This cobalt bond between this both carbon in this. Okay. After that, here second molecule of one first carbon of alkene, second carbon of alkene. After that, your carbonyl compound is showing this color, this type of structure. Okay. Here, reductive elimination techniques. Reductive elimination take place and formation of 5-member cyclic ring will be formed. Here, 1, 2, 3, 4 and 5. Okay? This 5-member ring will be formed new. Here, this cobalt, okay, this cobalt is eliminated, cobalt group with these 3 molecules of CO. Let's see what will be the bond form. This carbon number 1 and 5 member of carbonyl carbon will be formed new bond. And this carbon number 1 and this cobalt, that bond will be break. Okay? Now, we get 5 member of cyclic ring. First position having a 2 substituent. We simply numbering first 1, 2, 3, 4 and at 5th number of carbon your carbon group. Okay. After this bond breaking, then what will be the remaining part? Here carbon number 1 and carbon number 2 is having a cobalt bond. Okay. This cobalt again this cobalt which is joined to the their next or second cobalt compound with 3 carbonyl group. Here, shall I write this? After that, here, reductive elimination again takes place. Then here this bond will be break and formation of carbon-carbon double bond between carbon number 1 and second, and this will be eliminated. Then what will be the gate? And catalyst CO6 or simply 2 cobalt and 6 carbon. Okay, here it is our alpha beta cyclo penta. No. Okay, I think it is very simple mechanism, simple way mechanism. It is very important reaction for cyclization. After that finish, we can summarize that reaction. Now, this mechanism will be summarized in some step. Here, first, our dicobalt octacarbonyl species, which is 18 electron species, undergo the dissociation and 2 molecules of CO is lost. Here, we get 16 electron species. Okay, we can mention here 16 electron species, which coordination with alkyne or coordination of alkyne with this catalyst. Then we get this type of the molecule. Here formation of new bond between these two alkyne carbon and this cobalt carbon. This carbon will be form new bond this cobalt, first cobalt molecule and second cobalt molecule, again same this, and these three carbonyl substrate and these three carbonyl substrate as removed. After that, loss of one CO molecule. Okay, then we lost here this CO molecule. Then we get this type of the molecule. After insertion of alkene, here alkene insert between alkyne carbon and cobalt bond. Here this bond will be break, and here insertion of alkene. Okay, what will be the product form? This cobalt will form new bond between this alkene carbon, and this alkene carbon again form new bond with alkyne. Okay, here this alkene is new addition. After that, alkene insertion, addition of one carbonyl compound on this cobalt. After that, addition of two carbonyl is converted into three carbonyl group. After that addition, migratory insertion of take place of CO between the cobalt and alkene. Okay, this alkene, here insertion of this carbonyl group, which indicate by green color. This cobalt and alkene bond will be break again, and formation of new bond between carbonyl, cobalt carbonyl and alkene carbon. Okay, after again addition of new CO molecule. Okay, new addition of new CO molecule. Here, after the addition of new CO molecule, again this is moiety will be given. Okay, after that reductive elimination takes place. In the reductive elimination, we form 5 member of ring, 1, 2, 3, 4, 5. This bond will be break and this bond will be break, and formation of new bond between the carbon number 1 and carbon number 5. Here, let's the numbering 1, 2, 3, 4 and 5. Your 5 number carbon having a carbonyl group and 1 number having a R group. Okay, 1, 2. But after the bond breaking, only remaining which bond? This 1 and 2 and 1 cobalt molecule. Okay, this moiety is as removed. After finally reductive elimination takes place, and finally we get 5 member ring, which called as alpha beta cyclopentanone and CO2 CO6. It is 16 electron species. Okay, here dicobalt hexacarbonyl compound. Okay, which is our alpha beta cyclopentanone. Okay, we get our final product. Focus on this product. Okay, it is very simple. First dissociation take place of catalyst, then 16 electron spaces form, insertion or coordination of alkyne with catalyst. After that, formation of 4 bond between 2 carbon and cobalt, and then again loss of 1 carbonyl compound and insertion of alkene. Okay, after the insertion, the alkyne carbon and cobalt bond breaking and formation of new bond between alkyne carbon and alkene carbon and cobalt. Okay, after that addition again 1 CO molecule. After the CO molecule addition, then migratory insertion of CO. Here formation of new carbonyl group between the cobalt and alkene carbon. After that addition take place of new carbonyl compound. Then lastly reductive elimination take place. Okay, it is very easy step. Thank you.